Welcome to another lesson of SDL. Let's get started. Here I have the current game as is right now. We can move and there's collision. If you try to move into a wall. Now on the right hand side I have a picture. I have a green tile at the top left and I have a red tile here at the mid right hand side. Now the goal of the labyrinth is to go from one point to the other. Let's call the starting point the entrance. Let's call the end point the exit of the labyrinth. Our goal is to implement the entrance, that is the starting point, and the exit. Now the entrance and the exit will be determined by the game map. The game map will set the starting point. The game map will set the ending point for the player, for the exit of the labyrinth. The screenshot here on the right hand side is an arbitrary location for starting and ending point. It could be anywhere you want. That will be set by the game map. So what we're going to do is the following. We are going to change the game map.txt format to include information about the starting point and the end point for the player. Then we are going to perhaps make it more obvious to the player where those points are. Maybe we can color them in green and red, like it's shown in the screenshot on the right hand side. So essentially what is going to happen is whenever the player moves, we are going to check, did the player move into the labyrinth exit tile? If that is the case, then it's game over and the player wins. Otherwise, we continue the game. Now, if the game is already over, we will prevent the player from moving further, so there will be nothing else left to do. The player will have the option of starting a new game after pressing a key. Let's call the key perhaps the R key for restart. Later on, we'll learn how to add a text to the screen using SDL TTF. We'll look into that later on. Alright, so let's get started. First, let's change the game map format. So, going to game map.txt, we already have this format where each number, each integer represents the ID of the tile that is drawn on the screen. Each line corresponds or maps exactly to the line on the screen. So the first line would be the first line of tiles, second line would be the second line of tiles on the screen, and so on. Same thing for the column, they'll map exactly. Now what we can do is, before all of that, I can include information about the starting point and the end point. I'm going to do in the following way. For the starting point, I need the X and the Y. Okay? Now, I could use a raw position with, for example, 0, 32, 64, 96, something like that. Or I could simply specify the line and column at which the player will start. That way in the program it will automatically map those to an actual coordinate X, Y. So let's say I want to start the player. Right now the player starts, if I rerun the program here, right now the player starts at the very top left, right? The position is 0 for X, 0 for Y. That'll be the first line, the first column. Let's say we want to start in, let's say, the fourth line the fourth line, 1, 2, 3, fourth line, first column. That would mean I have to walk 0 steps in the X. So that would be index 0 for X, space 0, 1, 2, 3, index 3 for Y. Right? Because we start counting from 0. If it's the fourth column, that means it's 4 minus 1, which is 3, index 3. So let's consider that the starting position. Now for the ending position, let's say we want to end up in, what can we do right now? Let's see. Let's say it's the, let's count. For X, I am going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's correct. 20 minus 1, right? So let's do X 19, the last column. Now for the row, let's say 0, 1, 2, 3, 4, 5, 6. Let's call it the 7th row, which is index 6. That will be immediately, if you can project this to the left, it would be under, immediately on the line before this blob here with 2 white tiles. Okay, so that's what we expect to be the ending. So now we have 0, 3 for the starting point, 19, 6 for the ending point. Now with that, we have to change our code, right? Because right now our code expects only the lines and columns that were there before. It doesn't expect this very first line with the starting and ending point. So go to main.cpp. Wherever the map is being parsed or loaded, right? Now we have something else to do. Right here we open the file, we have an IF stream, and we are doing a loop, and then we close the file. Now what is going to happen before that is we have to capture the positions. Now let's call the entrance, labyrinth entrance, and the labyrinth exit positions. So assume there is a SDL rec for the entrance position. Okay. And there is an SDL rec for the exit position. We are going to do the following. Let me fix the screen. Okay. So we are going to get, since we just opened the file, we are in the very first line. The very first thing that we can see in, okay, we're going to see in, that is, we already have the stream, so game map file instead of see in. We're going to add to the position X first, and then later you're going to get the entrance position Y. Then you do game map file, the same thing. Now instead of entrance, it's going to be exit position X, then grab exit position Y. And no dot there. What this is doing is, for the assume that this is an SDL rec and this is going to be an integer, right? Some kind of integer. It's going to grab the first one, 0, and place in entrance position.x. It's going to grab the number immediately after that, which is 3, and put it inside entrance position.y. Then later exit position.x, exit position.y. And then it goes on to do whatever it was doing before. Now we need to pass these positions. So let's add here as a variable Let's call it SDL rect entrance position, SDL rect exit position. Now the thing is, we are modifying the value of entrance position and exit position. The way it's written right here, the arguments would be passed by value. That is, a copy of them would be reflected here, but changes inside this function would not be reflected outside to the callee. So we should either make this a pointer or a reference. I'm going to use the ampersand to make it a reference, so whenever we change it inside this function, it will reflect outside to whoever called it, the scope of whoever called it. Now go to the call to load game app. Now we have to pass those new variables. So I'm gonna call SDL rect entrance position, and I'm gonna declare not SDL rect for the exit position, and I'm gonna pass them here exit position. All right. Now, if you want to debug that, we already have this debug for the game map. We can also pass those in to make a debug statement. Okay, to see if everything actually was parsed correctly. And all it's going to do is, we can say before this loop, std : cout entrance, let's call it parentheses entrance position dot x, comma entrance position dot y, and I'm going to put a closing parenthesis and std end line. Now with that, I need to add here to SDL rect entrance position. I don't need to make it a reference here with the ampersand because I'm not changing entrance position at all. I'm just displaying the value. It's a read-only operation for this function. The same thing can be done. I can just copy and paste for the exit. So instead of entrance, just say exit, and it's going to display the x comma y inside parentheses. So here I'm going to say exit position instead of entrance position. Let's try it out with the new map format. Seems like we have some errors. Let's address those. I forgot to declare the third parameter as the rect exit position. Try it again. Now we got that. Now it's saying that the starting position that was parsed is 0,3. That's correct. Here on the left hand side is what it got. On the right hand side is the actual value. That's correct and matches. Now for the exit would be 19,6. We have 19,6 inside the game, so everything is working fine. Now that's awesome, but it doesn't start in 0,3. So we have to change the player initial position. Let's do that. Here, wherever we declare the player position, in the main function, we can do, where's the player position here? This is where player position is. Now the problem is we only get the entrance after loading the game map. So we have the entrance position, we load the game map, we got the entrance. From line 79 and down, we do have the entrance position, so we can take that into account when we make the player position. So we can say for the X for the player, instead of 0, we can say entrance position dot x. For the y, comma, entrance position dot y. Let's try it out. Recompile and run. And something is not right. What happened? Well, x right now is what? Is 0 and y is 3. So actually we didn't translate, right? Remember we had talked about instead of passing the actual coordinate, instead of defining the actual coordinate in the game map, we just passed the line number, actually not the line number, the index. The line index followed by the column index. So we need to multiply that by the tile size, which is 32, to be able to get the correct position here. Right? So if you take 3 multiplied by 32, right, we got 32, 64, right, 96. So that's what we need to do. So wherever you have load game map, let's go back. So the entrance position x and y, we have that. Now that's not correct, right? How can we do that here? Let's do the following. If I take int entrance line and do game map file x here, not that, sorry, I meant to do this like that. So we have int entrance line, and then we do game map file to entrance line, and then finally entrance position dot x would be entrance line times the tile size. We have do we have a constant for that? It's 32, but we can use the constant. We don't have a constant globally, but let's see. Did we declare that anywhere? We hard-coded them. Usually we wanna make a constant. So I'll make a constant here. And I'm gonna call the tile size will be 32. Since our tiles have the same width and height, I would just consider one variable. If your game had tiles that had variable size, then you would have to split this into 2 different variables, one for the width of the tile, another for the height. So with this global variable, let's reference that in the function here, tile size. So now we have this variable entrance line. Then we parse the very first integer in the map file, and then we multiply that by 32 to obtain the entrance position x. Do the same for y. So we can make another variable here, int exit entrance column actually, and then you do game map file, parse that into entrance column. That will give you the column index, right? You can call it entrance column index, and then we can do entrance position dot y would be the entrance column times tile size. Okay, of course you could make 78, 79 one line and so on. You can make this code better if you want. I'll leave as is. So the same thing for the other one. If you want to try out for yourself, pause the video and try it out, and then we do it together later. So how did it go? Let's keep going. So this time would be the exit, right? So it's essentially the same thing. So we would have a variable to hold the index for the line and column of the exit. So I'll call it exit line, exit column. You can put one line if you want to. Game map file, you can do like this to entrance, sorry, exit line, and you can do exit column, equivalent, same thing. That will be mapped consecutively. And then you can do entrance position, sorry, exit position X equals exit line. Oops, I actually made a mistake here. So I swapped the variables. So line is actually Y, right? So if you didn't catch that before, this is a very common mistake we can make when we're working with X and Y and lines and columns. Line actually is the Y position. So let's fix that. So here where I have interest positioned of X, entrance line, that's actually entrance column. Where I have the Y is actually entrance line, right? Because X goes from left to right, so that would be the column, right? And Y goes from top to bottom, so that would be the lines. Okay, so let's continue. We were in exit position X would be the exit column times the tile size. Exit position Y would be the exit line index times the tile size. Okay. Let's try it out to see if we didn't break anything. Entrance 96. Now you can see so let's take a look. Line 0 means Y equals 0. 96 comma Y 0. Correct. Column 3 means 3 times 32, X equals 96. Correct. Now check the exit. X would be corresponding with the column 6. 6 times 32 would be what? 5. 10 times 32, 320 divided by 2, that would be 160. 160 minus 32, 160, 130, 120. $128, so you add 128 to the half of 320, 160 plus, sorry, yeah, 160 plus 32. 192. Now for the other one, it'll be 19 times 32, be 608, is that correct? If you take 20 times 32, that'll be 640, minus 32, 608, that's correct. Okay. Now let's keep going. We got that parsed, and let's see. Seems like we jumped. We started, and so we want to start at the very first line and the third column. Is that correct? Is the gray tile there? Let's see. We are in the very first line. 1, 2, 3, 4. So index 3 is a fourth column. So that's correct. We are starting there. So that worked fine. Congratulations on reaching this point. Now let's try to see if I get out. I don't know where I started anymore. So maybe we want to paint that starting place with a different color. So let's go here. wherever we paint, remember we have the game loop. Let's think about this. Do we have to? Yeah, we have to. I'm thinking that we have to paint that starting point every time. Well, I don't think so. We can do it only once if you had the map texture already there or the surface. Let's see. Load, print, create game map surface. Of course, the player always has to be redrawn because the player is a moving thing, but the starting point does not move ever in this case. So we could just incorporate that into the game map surface if we wanted. Or we could paint as in a separate function here, and we do that before the game loop where it keeps drawing stuff. We can see the code to paint the player is here in line 216 and 217. We would do a similar thing to paint the starting point. I'm just gonna copy that. We can do after creating the game map. You can make a function here if you want, and you can say, let's say, paint or starting or entrance. Let's say paint entrance. And let's move this code to that function. Let's create paint entrance outside. Void paint entrance. Paste the code, and let's figure out what we need as arguments and as the input and possibly the output. First, you have to pick the color for the entrance. Let's call it just color. It's a type uint32. Call SDL map RGB. Give the surface format, right? We need the surface format, so probably want to pass as argument the window surface. I'm going to pass a surface pointer here. I forgot SDL. Surface pointer, window surface. 128 for R. Well, we had used green, so maybe we want some RGB. So G would be green. We could try 255 for the value here for green, and last on the red and blue to see what it looks like. So finally you call fill rect. In the window surface, you need to tell it where on the window surface to paint. So that would be the entrance position. So we need that as one other parameter. That's SDL rect. We don't have to pass by reference because we're not changing it. But since we're doing the pointer here, right? Because this argument to SDL for rect is a pointer. So maybe you could use the pointer here, but I'll leave it as is. It's okay. And I'll change the name of the third argument to just color because we changed it here. It returns nothing. I don't know as fill rect has any return value of error or not. You can do your own research there and handle any errors accordingly. That's an exercise for you. Now we have paint entrance. The callee needs to pass the arguments. First is the window surface. Second would be the entrance position, and we have it in the same name here. Here's the entrance position. Here's the window surface. Let's try it out. I have a problem because line 164. Error, player position was not declared in this scope. Okay, I call the variable a different name. It should be called, the argument is entrance position, not player position. The second argument passed to SDL fill rect on line 164. Let's get out. Nothing happened. Okay. Why didn't that work? Let's think. Fill rect update window surface. Do we need to update the window surface? I wonder. Let me just copy this after line 200. Oops. That's not the issue. Let's see, I reverted that. Game map surface. Okay. Oh, I see. Maybe. Let's see. We have the window surface. What we're doing from line 188. Get the window surface. Load the game map. Create map game surface. Pass the tiles. Now this surface here for the game map is not yet painted on the, actually that is always painted on the window. So I think the problem here is you have the window, you created the game map surface, then you paint on the window, and then later here you are bleeding the game map surface over the window surface, so that will cover the green that we already have. So actually I did it. We should not paint the window surface. We have to paint the game map surface, because that will always be painted over the window surface. So let's change the argument here. For paint entrance, it's not the window surface. That would be the game map surface here. And let's change the parameter name because it's not really right. We can just call it surface, actually, to generalize the painting of the entrance in any kind of surface. So I changed the name of the parameter. Now let's try it out. Oop. No, what is going on? That's awful. Well, that's not good. Everything now is green to the right hand side there. Let's see what we can do. Well, let's go to it again. So we take the game map surface and paint the entrance position. Entrance position here would be 96,0. Oh, that's it. Now we didn't set the width and height for the SDL rect for entrance position. That's why it covered the whole thing there. So we need to limit the width and height to 32. So in the SDL rect for entrance position, let's initialize that with an x of 0, y of 0, and then width of 32, which is the tile size, height of 32, which is the tile size. That way we have some initial value, okay? And then there won't be any more problems there. Now you can see that the square only covers 32 by 32 of area. Okay, we're likely gonna face the same problem with exit position, so I'm just gonna take this opportunity to initialize exit position X to 0, Y to 0, then tile size 32 and 32 for width and height respectively. That way it has some initial value to fall back to for the case of X and Y, and it has the limited width bounded to 32 by 32 for width and height. Now that's looking great. Now we know where we started with that green tile here in the very first line, 4th column. Now since we did that, I want you to go ahead and paint the exit using the same approach. All right? All right, so let's go. Well, we could copy and paste the same very paint entrance function. That's one way. You can certainly generalize this to any kind of tile, but that's okay. We are going to make paint exit. We're going to take any surface, pointer to a surface, and the SDL rect of the position. I'm going to call it exit position. Define the color, UWin32 color equals SDL underscore map RGB. Take the format of the surface hyphen greater than format. The color we had used a red, some kind of red, so maybe I want to use 255 here and 128 for green and blue. Now take that color, SDL fill rect, the surface, comma, the ampersand is the address of exit position SDL rect, and then finally the color. And finally, let's call paint exit from where we called paint entrance. Same thing, pass the game map surface, exit position. Let's try it out. That didn't work, did it? What happened? Did I save? Paint exit game map surface exit position right here 0 0. Exit position is set in load game map. I hope it's at 192.608. That would be where? Around 192 here, 19 here. Remember, I think we had set that to. Okay, I think if you take X 192 and Y 608, did we do something wrong here? I think we did. I think we swapped the thing again. What happened? Because there's no way you can have Y greater than 480, right? Because the screen height is 480. So I think we flipped this. Let's check it out. So if this is the line, that's correct. 19 is the line. Wait, 19. How many lines do we have? 480 divided by 32 would be 15. So that's actually wrong. We cannot have more than 15 here. So I messed up. I think I meant to say 6 and 19. So this would be the line, right? The 6th line. 1, 2, 3. Right, 1, 2, 3, 4, 5, 6. Hold on. I think I meant it to be here. So that would be 1, 2, 3, 4, 5, 6, 7. 7th line. 7 minus 1 is index 6, correct. Now I meant it to be at 19, so 20 across 20 tiles, -1, 19 is the index. Correct. So I had swapped my line and column here in the game map. All these things happens. Trial and error. Now you can finally see the red square here in the very middle point at the right hand side. That's where I meant it to be, and that's the exit that we have to go to finish the game and win. Of course, nothing happens now to indicate we won. That's something we're gonna do later. Okay, I think it's a good time for us to take a break, and I see you in the next one.